Hello everyone, welcome to Demystifying Networking, where we demystify complex networking concepts. In this video, we are going to have a look at a scenario-based question related to OSPF. In this scenario, we have three routers, router 1, router 2, and router 3. Router 1 is a member of area 11, while router 3 is a member of area 22. Router 2 is a member of both Area 11 and Area 22. Here, we are trying to ping from router 1 to the loopback 0 interface of router 3, and this ping is failing. In this video, we are going to see why this ping is failing and how to fix it. So let's get started and verify the ping from router 1 to router 3's loopback interface. As you can see, the ping is failing. The first thing in the troubleshooting process is to verify if router R1 has a route to the loopback of router 3. As you can see, router 1 does not have a route to the loopback of router 3. Now let's verify if router 3 has a route to the loopback of router 1. Router 3 also does not have a route to the loopback of router 1. As router 1 and router 3 does not have a route to each other's loopback interfaces, the ping is failing. Now let's try to see why router 1 and router 3 does not have a route for each other's loopback interfaces. The second step in the troubleshooting process is to verify if OSPF is configured correctly on all the three routers. So let's check on router 1 if OSPF is configured correctly. As you can see, OSPF is configured on router 1. Now let's verify the interfaces where OSPF is configured. As you can see, OSPF is configured on the loopback 0 and gigabit Ethernet 0/0 interface of router 1, and both interfaces have been configured to be under area 11. Now let's verify the OSPF neighborship on router 1. As you can see, router 1 is an OSPF neighbor with router 2. Now let's go to router 2 and verify its OSPF configuration. So the command output confirms that OSPF is configured on router 2 as well. Now let's verify the interfaces configured on router 2 for OSPF. As you can see, the gigabit Ethernet 0/0 interface of router R2 is configured to be part of area 11, and the gigabit Ethernet 0/1 interface of router R2 is configured to be part of area 22. Now let's verify the OSPF neighborship on router R2. As you can see, router R2 is an OSPF neighbor with router 1 and router 3. Now let's go to router 3 and verify its OSPF configuration. As you can see, OSPF is also configured on router 3. Let's verify the interfaces on which OSPF is enabled. So OSPF is enabled on the Loopback 0 interface and the Gigabit Ethernet 0/1 interface, and both of these interfaces are configured to be under Area 22. Let's verify the OSPF neighborship. So this command output confirms that router 3 is an OSPF neighbor with router 2. In the third step of the troubleshooting process, let's verify the link state databases on all the routers. Let's start with router 1. As you can see, the link state database on router 1 has two router LSAs and one network link state LSA. Now let's go to router R3 and verify its OSPF link state database. As you can see, router R3 has two router LSAs, one for router 2 and one for router 3. It also has one network link state for the link between router 2 and router 3. Now let's verify the contents of link state database on router R2. As we can see, the link state database on router R2 shows us information for two areas, Area 11 and Area 22. This is because router R2 has interfaces in both Area 11 and Area 22. In the link state database of Area 11, we see that router R2 has two router LSAs, one for router 1 and one for router 2. Router R2 also has a network link state LSA for the link between router 2 and router 1 in Area 11. If you look at the link state database for Area 22, router 2 has two router LSAs, one for router 2 and one for router 3. It also has a network link state LSA for the link between router 2 and router 3. The step number 4 of the troubleshooting process is to verify if the right type of LSS has been generated by the routers. If you look at the link state database of router 1, we do not see any type 3 summary LSS generated. If you go to router 2, we also do not see any type 3 summary LSS generated. If you go to router R3, R3 also does not have any type 3 summary LSS generated in its link state database. If you closely look at the topology diagram, you will realize that router 1 and router 3 are member of two different areas. Router 1 is a member of area 11, while router R3 is a member of area 22. To establish reachability between router 1 and router 3, we need an area border router that generates type 3 LSAs for the prefixes in area 22 into area 11 and for prefixes in area 11 into area 22. The next step in the troubleshooting process is to verify if router R2 is announcing itself as an ABR. We can verify that by having a look at the router LSA advertised by router R2. As you can see on your screen, The router LSA generated by router R2 for area 11 does not announce router R2 as an ABR. If we look at the router LSA advertised by router R2 for area 22, it also does not announce router R2 as an ABR. For router R2 to be an ABR, at least one of its interface needs to be in area 0, and that interface should not be in the down state. So let's verify if router R2 has at least one interface in area 0. As you can see, router R2 has one interface gigabit 0/0 in area 11 and gigabit 0/1 in area 22. It does not have an interface in area 0, and that is the reason R2 does not announce itself as an ABR in its router LSA. To make router R2 announce itself as an ABR, we need to configure at least one of its interfaces in area 0. So let's configure interface loopback 0 on router R2 in OSPF area 0. Now let's verify if interface loopback 0 is seen in area 0. So the command output verifies that now R2 has an interface loopback 0 in area 0. Let's verify if router R2 is now announcing itself as an ABR in its type 1 router LSA. As you can see on your screen, the router LSA advertised by router R2 in area 0 advertises itself as an area border router. If we look at the router LSA advertised by router R2 in area 11, it advertises itself as an area border router. And the same thing is about area 22. So now R2 is acting as an ABR. Now, since R2 is announcing itself as an ABR, let's verify if R2 is generating type 3 summary LSAs. As you can see, R1 has received a summary LSA for the loopback of router 2 and also for the loopback of router 3. Router 2 also advertises a summary LSA for the link between router 2 and router 3. Now let's go to router R3 and verify if router R2 is also advertising summary LSAs in area 22. So here you can verify R2 has advertised a summary LSA for the loopback of router 1, for the loopback of router 2, and for the link between router 1 and router 2. Let's verify the routing table on router R1. As you can see, now router R1 has a route to the loopback of router 3. Let's verify on router 3 if it has a route to the loopback of router 1. So the command output confirms that router 3 has a route to the loopback of router 1. Now let's try to ping from router 1 to the loopback interface of router 3. And as you can see, the ping has now succeeded. The lessons learned in this video. Internal routers have reachability to only prefixes in its own area. In our sample topology, router 1 and router 3 are internal routers, and they have visibility only to the prefixes in their own areas. In order to have reachability to inter-area prefixes, the internal routers rely on ABR routers that generate Type 3 summary LSA. At the beginning of the video, router R2 was not announcing itself as an ABR, and hence it was not generating Type 3 summary LSAs that prevented router 1 and router 3 to have reachability information to each other. An ABR is an OSPF router that connects multiple areas. But for a router to be an ABR, it must have at least one interface in area 0, and that interface must not be in a down state. And that is the reason we configured the loopback 0 interface on router R2 as a member of area 0. If you found this video useful, please like and share this video and subscribe to Demystifying Networking for more such useful content.